December 7th, 1944, somewhere along the frozen supply route between Bastogne and Luxembourg. Oberst Heinrich von Lüttichau stood in the deep snow, watching an American convoy pass on the road below his observation post. 43 trucks rolled past in 30 minutes, each one a GMC CCKW, 2.5-ton cargo truck, painted olive drab, their canvas covers bulging with supplies. What struck him most was not their number, though that was impressive enough. It was the sound. The engines ran with a mechanical consistency that seemed almost unnatural to ears accustomed to the grinding, sputtering variety of German motor pools. Each truck sounded nearly identical to the last, a low rumble that spoke of standardization on a scale the Wehrmacht had never achieved. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. In his field journal that evening, von Lüttichau wrote something that would later be found among captured German documents. The Americans have achieved what our logistics officers insisted was impossible. They have created a supply vehicle that operates in all conditions, with apparent indifference to terrain, weather, or mechanical stress. More troubling, they have built these vehicles in such quantities that they treat them as disposable. A truck with minor damage is simply abandoned. Another appears within hours to replace it. This is not war as we understand it. This is industrial production applied to military operations on a scale that renders traditional calculations meaningless. What von Lüttichau witnessed that winter afternoon was merely a fragment of the largest military vehicle, production program in history. Between 1941 and 1945, American factories would produce approximately 562,000 GMC CCKW trucks, known universally to the soldiers who drove them as the Deuce-and-a-Half. These vehicles would haul ammunition through North African deserts, supplies across Pacific islands, and wounded soldiers through Italian mountains. They would ford rivers in Burma, climb mountain passes in the Himalayas, and navigate frozen roads across northern Europe. German military planners, who had calculated precisely how many trucks various nations could produce, had never imagined that a single standardized vehicle design could be manufactured in such quantities while maintaining consistent quality and reliability. The story begins not with German recognition, but with German confidence. In the planning rooms of Berlin during 1940 and 1941, Wehrmacht logistics officers calculated Allied industrial capacity with Germanic precision. They knew that Britain's truck production had peaked at approximately 100,000 vehicles annually before the war. They knew that Soviet factories, before German invasion, produced roughly 150,000 trucks per year. They knew that France, now occupied, had produced perhaps 70,000 military vehicles at maximum output. These numbers, carefully tabulated and analysed, suggested that the Allies would face severe vehicle shortages. The mathematics seemed inescapable. What German planners underestimated was not American industrial capacity in the abstract. Intelligence reports correctly identified that American automobile production exceeded 3 million vehicles annually in peacetime. The miscalculation lay in believing that civilian production methods could not translate rapidly to military requirements. German military vehicles were purpose-built in specialized facilities by workers trained in military specifications. Transitioning from civilian automobiles to military trucks required years of preparation, factory retooling, workforce training, and supply chain reorganization. At least, this was true in Germany. The German assumption proved catastrophically wrong in the American case. The GMC CCKW emerged from requirements developed by the United States Army in 1940. Military planners specified a cargo truck capable of carrying 2.5 tons cross-country, operating in any climate from Arctic cold to tropical heat, fording streams up to 30 inches deep, climbing grades up to 60%, and being maintained by minimally trained personnel using common tools. The specifications were demanding, but not unprecedented. What was unprecedented was the Army's insistence on complete standardization. Rather than accepting different designs from multiple manufacturers, The Army wanted one design built by all participating companies with fully interchangeable parts. General Motors' truck division in Pontiac, Michigan, received the contract to develop what would become the CCKW. The designation itself reflected military standardization. C indicated the vehicle was designed in 1941. The second C meant it was a conventional cab design. K meant all-wheel drive. W meant dual rear axles. Soldiers, indifferent to military nomenclature, called it the Deuce-and-a-Half, referring to its cargo capacity in tons. The name stuck. GMC engineers had less than 9 months to move from prototype to production. They began with proven components. The engine was a GMC Model 270 cubic inch inline 6-cylinder gasoline engine, producing 91 horsepower at 2,750 revolutions per minute. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. This was not cutting-edge technology. The engine design dated to the late 1930s, but it was reliable, powerful enough for the chassis, and most critically, GMC already had production lines capable of building it in vast quantities. The transmission was a 5-speed manual, again using proven technology. The transfer case provided high and low-range gearing for the all-wheel drive system. Front and rear axles were heavy-duty designs adapted from existing GMC truck components. The chassis was a straightforward ladder frame. The cab was stamped steel with a canvas top. The cargo bed featured removable bows supporting a canvas cover. Nothing about the design was revolutionary. Everything about it was practical. The first production CCKW rolled off the assembly line in January 1942, just weeks after Pearl Harbor. Initial production was modest, several hundred vehicles monthly, but GMC was simultaneously expanding its facilities. By mid-1942, production reached 2,000 trucks monthly. By late 1942, monthly output exceeded 4,000. By 1943, GMC was building more than 10,000 CCKW trucks every month. The production acceleration continued. Peak production in 1944 saw GMC factories deliver over 15,000 Deuce-and-a-Half trucks monthly. The scale was staggering. At maximum production, GMC completed one truck every 3.5 minutes, 24 hours a day, 7 days a week. The standardization extended beyond the vehicles themselves. GMC established precise specifications for every component. Suppliers across the United States manufactured parts to these specifications. An engine block cast in Wisconsin would fit perfectly with a transmission built in Ohio and an axle from Michigan. This interchangeability created enormous advantages. A mechanic in North Africa could repair a truck using parts from a supply depot that had never seen that particular vehicle. Units could cannibalize damaged trucks to keep others running. Battle damage that would have rendered a German truck irreparable for lack of specific parts could be fixed on an American truck in hours using standard components. The German military, by contrast, operated a bewildering variety of truck designs. Opel, Daimler-Benz, Bussing, Henschel, Magirus, and dozens of smaller manufacturers each produced military trucks to different specifications. An Opel Blitz 3-ton truck could not share parts with a Mercedes 3-ton truck, despite serving identical functions. German supply officers faced nightmares trying to stock appropriate parts for the mechanically diverse vehicle fleets in their units. A panzer division might operate trucks from 8 different manufacturers, each requiring unique spare parts. This complexity created vulnerability. A unit might have disabled trucks awaiting specific parts while other trucks operated, unable to share components. The German approach reflected peacetime thinking where manufacturers competed and maintained proprietary designs. The American approach reflected industrial warfare, where standardization created strategic advantage. The first significant encounter between German forces and American Deuce-and-a-Half trucks occurred in North Africa during Operation Torch in November 1942. When American forces landed in Morocco and Algeria, they brought thousands of GMC trucks ashore in the initial waves. German intelligence officers in Tunisia received reports of these vehicles within days. Initial assessments were mixed. The trucks appeared utilitarian, lacking the refined engineering visible in German vehicles. They were larger and heavier than comparable German trucks, suggesting inefficiency. The all-wheel drive system seemed unnecessarily complex for a cargo truck. One intelligence report from December 1942 noted that American trucks showed crude construction methods with exposed welds, bolted assemblies instead of integrated designs, and components that appeared oversized for their function. What German analysts missed was that these apparent inefficiencies were deliberate design choices that enhanced reliability and maintainability. Exposed welds could be inspected visually, bolted assemblies could be disassembled with basic tools. Oversized components provided safety margins that prevented failures under stress. The crude appearance masked sophisticated engineering thinking about how vehicles would actually be used and maintained in combat conditions. German military trucks, by comparison, often featured elegant engineering solutions that worked beautifully when new and properly maintained, but became nightmares when damaged or when proper maintenance became impossible. The first German prisoners captured in Tunisia during early 1943 had witnessed American logistics operations firsthand. During interrogations at collection points, they consistently mentioned the abundance of American trucks. Captured after the Battle of Kasserine Pass in February 1943, these prisoners described American supply convoys that stretched for miles, trucks moving constantly, regardless of road conditions or weather. Lieutenant Karl Bruckner, a supply officer from the 10th Panzer Division, provided detailed observations during his interrogation. He noted that American units appeared to have unlimited vehicle capacity. When roads became impassable, American trucks simply drove cross-country. When vehicles broke down, they were often abandoned rather than repaired, suggesting either remarkable wealth or remarkable stupidity. He could not determine which. What Bruckner could not know was that American logistics doctrine emphasized maintaining operational tempo rather than conserving equipment. A broken truck that would take 6 hours to repair was abandoned if a replacement truck could arrive in 2 hours. This approach horrified German logistics officers trained to carefully husband scarce resources, but the mathematics were inescapable. American industrial production delivered replacement trucks faster than German mechanics could repair damaged ones. Time, not equipment, was the constraining resource for American forces. The specifications of the CCKW explained much of its capability. The truck measured 216 inches long, 87 inches wide, and 94 inches high with the cab top up. Wheelbase was 145 inches. Curb weight approached 9,000 pounds. With a full 2.5-ton cargo load, total weight reached 14,000 pounds. The truck rode on 920 tyres, the same size used on some American tanks. These large tyres provided ground clearance of 10 inches and distributed weight across a large contact patch, reducing ground pressure and improving off-road mobility. The engine's 91 horsepower might seem modest, but it provided adequate power for the loaded vehicle. Maximum speed on paved roads approached 45 miles per hour. More importantly, the truck could maintain 25 miles per hour across rough terrain that would force German trucks to slow to walking pace or stop entirely. The all-wheel drive system meant the truck could climb grades that two-wheel drive vehicles could not attempt. The low-range gearing provided immense torque multiplication for extreme conditions. Fording capability of 30 inches meant the truck could cross streams that would stop conventional vehicles. German 3-ton trucks, the nearest equivalent in Wehrmacht service, typically featured two-wheel drive, less powerful engines producing 60 to 70 horsepower, and limited off-road capability. The Opel Blitz, probably the best German military truck, weighed less and used less fuel than the American Deuce-and-a-Half, but its rear-wheel drive system meant it required paved or well-maintained roads to operate effectively. In the deserts of North Africa, the mountains of Italy, or the mud of Northern Europe, German trucks regularly became stuck while American trucks continued moving. The collapse of German forces in Tunisia in May 1943 resulted in the capture of approximately 250,000 Axis soldiers, including thousands of German troops. These prisoners were processed through Allied facilities, then transported to prison camps. Many of them traveled in American trucks. The journeys provided extended exposure to American vehicle capabilities. Obergefreiter Hans Richter, captured near Tunis, described a 3-day journey from the capture point to a coastal prison camp. The route crossed terrain that would have been impossible for German trucks without extensive road preparation. American drivers simply shifted into 4-wheel drive and continued. The trucks climbed rocky slopes, forded streams, and traversed deep sand without apparent difficulty. When one truck became stuck, another simply pulled it free. No drama. No extended recovery operations. Just practical problem-solving enabled by abundant mechanical power and standardized recovery equipment. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now, back to the story. Prison camps established in North Africa during spring and summer of 1943 often used German prisoners for labor details. These work assignments frequently involved loading or unloading American supply trucks. German soldiers who had served in supply units found themselves fascinated by American vehicle designs. Oberfeldwebel Martin Schaefer, a former mechanic with the Afrika Korps, spent weeks working at an American supply depot near Oran. He later wrote in letters that were intercepted but provide valuable documentation that American trucks showed remarkable consistency in manufacture. He inspected dozens of vehicles and found virtually identical construction. Panel gaps were uniform, welds appeared similar across vehicles, components were clearly standardized. In German production, each truck showed individual variation, as craftsmen made minor modifications during assembly. American trucks looked mass-produced because they were mass-produced, built by workers following precise specifications rather than experienced craftsmen exercising judgment. The psychological impact of this standardization proved profound. German military culture valued craftsmanship and individual skill. The idea that vehicles could be built by workers with minimal training following standardized procedures seemed to contradict everything Germans understood about quality manufacture. Yet the trucks worked. They worked consistently and reliably in conditions that would have tested carefully crafted German vehicles. The evidence suggested that standardized mass production could achieve results equal or superior to traditional craftsmanship, a conclusion that challenged fundamental assumptions about manufacturing and quality. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The production statistics became available to German intelligence through various sources during 1943. American newspapers, available in neutral countries, occasionally reported on war production achievements. Captured American documents included production statistics. Aerial reconnaissance photographed American factories. Intelligence analysts compiled data suggesting that American truck production exceeded anything they had previously calculated. The numbers seemed impossible. Reports indicated that American factories would produce over 500,000 military trucks in 1943 alone. German intelligence officers recalculated repeatedly, certain there must be errors in translation or interpretation. There were no errors. American truck production in 1943 exceeded 520,000 vehicles. GMC alone produced over 150,000 CCKW trucks that year. When analysts included production from other American manufacturers building different truck models, total American military vehicle production reached staggering levels. Germany, by comparison, produced approximately 100,000 military trucks in 1943, and that represented maximum output. The ratio was 5-to-1 in America's favor, and the gap was widening. The invasion of Italy in September 1943 brought German forces into sustained contact with American mechanized logistics. The terrain of Italy, with its mountains, narrow roads, and seasonal mud, should have favored defenders and created enormous difficulties for attackers trying to maintain supply lines. German forces had planned their defensive strategy around the assumption that Allied logistics would struggle in Italian conditions. The appearance of thousands of American Deuce-and-a-Half trucks climbing mountain roads that German planners had considered impassable for heavy vehicles forced a rapid reassessment. General Major Rudolf Siechenius, commanding artillery units in the Gustav Line defenses, observed American supply operations through field glasses during winter 1943–44. His observations, recorded in after-action reports, noted that American trucks operated continuously, regardless of weather conditions. Rain, snow, and mud that immobilized German transport barely slowed American convoys. The trucks climbed mountain roads with grades that German vehicles could not attempt. Most remarkably, American drivers seemed almost cavalier about their vehicles, pushing them hard and accepting mechanical failures as inevitable rather than catastrophic. The reason became clear when disabled trucks were simply abandoned and replacement vehicles appeared within hours. The human cost of logistics failures created stark contrasts between German and American operations. German wounded in Italy often faced evacuation delays, measured in hours or days as scarce transport capacity was allocated to ammunition and fuel. American wounded were evacuated in minutes. Every American combat unit had Deuce-and-a-Half trucks modified as ambulances, with fitted stretcher racks that could carry up to 8 wounded soldiers. These ambulance trucks could reach forward positions that conventional ambulances could not access, retrieve wounded personnel, and deliver them to field hospitals while traversing terrain that would stop German ambulances. The impact on survival rates was measurable and significant. American soldiers knew that if wounded, they would receive medical attention quickly. German soldiers knew that wounds often meant extended delays before treatment. Oberst Wilhelm Maus, chief supply officer for the 14th Army in Italy, wrote in a suppressed report to Berlin in February 1944 that American logistical superiority was becoming decisive. His report noted that German forces moved supplies using a mixture of trucks, horse-drawn wagons, and Italian civilian vehicles pressed into service. This patchwork system worked barely adequately in static defensive positions but collapsed completely when units needed to maneuver. American forces, by contrast, moved supplies with standardized motor transport that operated independently of road conditions. An American division could reposition its entire supply system in hours. A German division required days. This mobility advantage meant American forces could concentrate combat power faster and sustain operations longer than German forces with equivalent manpower. The specific capabilities of the CCKW enabled operations that German logistics officers considered impossible. The truck's fording capability meant rivers that German forces treated as significant obstacles were minor inconveniences for American supply columns. The all-wheel drive system meant American trucks could operate in mud conditions that brought German logistics to a halt. The standardized design meant maintenance could be performed by personnel with minimal training using universally available parts. German maintenance, by contrast, required skilled mechanics with access to vehicle-specific components. These accumulated advantages created operational tempo that German forces could not match. German forces did capture American trucks in Italy, though in smaller numbers than they captured jeeps. Every captured Deuce-and-a-Half was immediately pressed into service. German units operating captured American trucks filed reports that were remarkably consistent in their assessments. The trucks were more capable than German equivalents, easier to maintain, and sufficiently abundant that capture of even a few vehicles provided significant capability enhancement. Hauptmann Friedrich Vollmer, commanding a supply company in the Gothic Line defenses, operated 3 captured American trucks for several months in autumn 1944. His unit report noted that these 3 trucks, properly maintained with parts from captured American supply dumps, provided more reliable transport capacity than his 8 German trucks, which suffered constant mechanical failures and parts shortages. The challenge for German forces operating captured American vehicles remained fuel. The CCKW consumed approximately 15 miles per gallon when driven conservatively, worse when operated hard or in extreme terrain. German trucks achieved somewhat better fuel economy. But by late 1944, fuel shortages had become so severe that fuel consumption comparisons became almost irrelevant. German logistics was collapsing not because vehicles were inefficient, but because fuel supplies had been cut by Allied bombing of refineries and interdiction of transportation networks. Some German units operating captured American trucks resorted to distilling alcohol for fuel or using wood gasification systems, expedients that kept vehicles marginally operational but at drastically reduced performance. The invasion of France in June 1944 demonstrated American logistical capability at scales that shocked German observers. Operation Overlord required landing supplies for armies measured in the hundreds of thousands of soldiers. The invasion beaches, particularly Omaha Beach, had no port facilities. Everything came ashore across open beaches. German defensive plans had assumed that Allied logistics would struggle without captured ports. The assumption proved wrong. American engineers built the Mulberry artificial harbors, but more importantly, American trucks simply drove through shallow water to reach the beaches. The CCKW's 30-inch fording capability meant trucks could drive into water deep enough to reach landing craft ramps, take on cargo, and drive back to shore. This capability transformed the beaches into functional ports capable of handling thousands of tons daily. General Feldmarschall Erwin Rommel, commanding German forces defending Normandy, understood the implications. In reports to Berlin before his injury in July 1944, Rommel noted that Allied material superiority was overwhelming. German forces fought with ammunition rationing while Allied artillery fired without apparent constraints. German infantry walked while Allied infantry rode. German supplies moved at night to avoid air attack, while Allied supplies moved continuously regardless of air threat. The weight of material, Rommel wrote, was crushing German defensive capabilities. Superior German tactics and soldier quality could not overcome material disadvantages measured in orders of magnitude. The liberation of Paris in August 1944 and the subsequent pursuit across France saw American mechanized logistics operating at maximum tempo. The famous Red Ball Express, a convoy system that operated from Normandy beaches to forward units, moved over 12,000 tons of supplies daily at its peak. The Red Ball consisted primarily of Deuce-and-a-Half trucks driving in continuous convoys along dedicated routes. Drivers operated in shifts, pushing vehicles hard and accepting that mechanical failures were inevitable. Maintenance units stationed along routes performed repairs on disabled trucks. Trucks beyond quick repair were simply pushed off the road and abandoned. Replacement vehicles came from the endless stream of trucks arriving from American factories. German intelligence officers analyzing the Red Ball Express concluded it represented logistics thinking fundamentally different from German doctrine. German military training emphasized careful vehicle maintenance and conservation of resources. Drivers were trained to operate vehicles gently to extend service life. Maintenance was performed meticulously. Disabled vehicles received extensive repair efforts. This careful husbanding of resources made sense when replacement vehicles were scarce. American logistics accepted that maintaining operational tempo mattered more than conserving individual vehicles. Pushing trucks hard resulted in more mechanical failures but delivered supplies faster. The calculation was simple. American factories produced trucks faster than combat operations could destroy them. Time, not trucks, was the limiting factor. The contrast became even more pronounced during the Battle of the Bulge in December 1944. German forces launched their last major Western offensive through the Ardennes forest, hoping to reach Antwerp and split Allied armies. The operation depended on capturing American fuel supplies because German logistics could not support sustained offensive operations. The plan required German mechanized units to overrun American supply dumps and use captured fuel to continue advancing. This dependence on enemy supplies for operational sustainability revealed the desperation of German logistics by late 1944. The offensive initially achieved surprise and territorial gains. German forces captured American supply dumps containing enormous quantities of fuel, ammunition, food, and equipment. Yet even these captures could not sustain German operations. The infrastructure required to distribute captured supplies did not exist. German trucks, suffering from mechanical failures and fuel shortages, could not efficiently move captured materials. American forces, by contrast, rapidly adjusted logistics to support the defense. Thousands of trucks rerouted to deliver ammunition to embattled units. The 101st Airborne Division, encircled at Bastogne, received supply drops by air, but when the siege broke, relief came on roads cleared and supplied by endless convoys of Deuce-and-a-Half trucks. General Oberst Alfred Jodl, chief of the German Armed Forces Operations Staff, later testified during his war crimes trial that the Ardennes offensive failed primarily due to logistics. German forces could not move supplies fast enough to sustain offensive operations. American forces could concentrate material faster than German forces could advance. The offensive, he noted, demonstrated that modern mechanized warfare belonged to nations with industrial capacity to build and operate vast mechanized logistics systems. Germany, by late 1944, lacked this capacity. The Wehrmacht was reverting to horse-drawn transport while facing an enemy with unlimited motorized logistics. The final months of the war saw complete German logistics collapse. By March 1945, German forces in the West operated with perhaps 20% of their vehicle fleet still functional. Fuel allocations fell to levels that permitted only emergency movements. Ammunition supplies dwindled to handfuls of rounds per gun. Food distribution broke down. German soldiers foraged or starved. American forces, advancing rapidly across Germany, operated with full logistics support. Supply trucks followed advancing units, delivering ammunition, fuel, food, and mail. The contrast could not have been more complete. German soldiers defending their homeland faced supply crises, while American soldiers hundreds of miles from their ports received regular deliveries of every necessity. German officers captured during the final campaigns consistently mentioned American logistics when interrogated. General Lieutenant Fritz Bayerlein, who had commanded the Panzer Lehr Division, told interrogators that American material superiority made defeat inevitable. German forces, he noted, could win tactical engagements through superior tactics and soldier quality. But tactical victories meant nothing when American forces simply absorbed losses and continued operations using fresh supplies delivered by unstoppable logistics. He specifically mentioned American trucks as embodying this advantage. They were everywhere, carrying everything, enabling operations that German forces could not contemplate. The statistics reveal the magnitude of American achievement. GMC produced approximately 562,000 CCKW trucks between 1941 and 1945. This represented roughly 1/4 of total American military truck production, which exceeded 2 million vehicles. Germany produced approximately 150,000 military trucks total during the entire war, including all models from all manufacturers. The ratio was roughly 14 American trucks for every German truck. This numerical advantage, combined with superior American logistics doctrine, created overwhelming operational capability. The Deuce-and-a-Half served in every theater where American forces fought. In the Pacific, trucks drove through jungles on islands where roads barely existed. In China, Burma, India, trucks drove the Lido Road and the Burma Road, mountain routes where one side dropped hundreds of feet and the other side rose vertically. In Alaska, trucks operated in extreme cold that froze lubricants and made metal brittle. In North Africa, trucks operated in heat that boiled coolant and sand that abraded every moving part. In Europe, trucks operated through mud, snow, and ice. The vehicles' adaptability to extreme conditions reflected robust design margins and component over-engineering that German efficiency experts would have criticized as wasteful. Yet this apparent waste created reliability. Overbuilt components rarely failed. Large tolerances accommodated thermal expansion and battlefield damage. Simple designs allowed field repairs. The engineering philosophy behind the CCKW prioritized operational availability over theoretical efficiency. A truck that operated at 80% mechanical efficiency but maintained 95% operational readiness, was strategically superior to a truck that operated at 90% efficiency but achieved only 60% readiness due to maintenance requirements. German vehicles often represented the latter category. American trucks exemplified the former. The human dimension of American logistics reflected democratic mobilization on an unprecedented scale. The Red Ball Express, symbol of American logistics achievement, was operated primarily by African American soldiers. Approximately 75% of Red Ball drivers were black troops serving in segregated transportation companies. These soldiers, denied combat roles by military racism, proved essential to military victory by keeping supplies moving. Their performance demonstrated that logistical capability mattered as much as combat capability in modern mechanized warfare. The trucks they drove became instruments of democratic victory despite the contradictions of a segregated military fighting for freedom. Women also contributed significantly to American truck production. By 1944, women comprised over 60% of the workforce in many American manufacturing plants. They operated stamping presses, assembled components, drove forklifts, and performed quality inspections. German factories, by contrast, relied heavily on slave labor and forced workers who had every incentive to sabotage production. The productivity differential was enormous. American workers producing vehicles for their nation's military performed at levels slave laborers could not match. This human dimension of production proved as important as any technical specification. The technological legacy of the Deuce-and-a-Half extended far beyond World War II. The basic design remained in American military service through the Korean War and into Vietnam. Trucks built in 1943 were still operating in the 1960s, testament to durability that far exceeded design expectations. Civilian versions appeared immediately after the war as surplus military trucks flooded the market. Farmers, construction companies, and logging operations bought surplus Deuce-and-a-Halfs for a fraction of their military cost. These trucks worked for decades in civilian roles, their military origins gradually obscured by modifications and repainting. The design influenced military vehicle development worldwide. The Soviet Union's ZIS-151 showed clear influence from captured American trucks. Britain's Bedford RL drew on lessons from wartime collaboration with American logistics. France's Renault TRM 2000, developed decades later, incorporated design principles proven by the CCKW. The fundamental concept of a standardized, mass-produced, all-wheel drive cargo truck became the global standard for military logistics vehicles. Every modern military operates vehicles that trace intellectual lineage to the American trucks of World War II. The German experience with American trucks provides lessons that extend beyond military history. Industrial capacity proved decisive in modern warfare. Germany entered the war with confidence in its technical superiority and tactical excellence. Both advantages existed and mattered in individual engagements. But strategic victory required industrial capacity to build and sustain mechanized forces. America possessed this capacity. Germany did not. No amount of tactical skill could overcome material disadvantages measured in orders of magnitude. Standardization created advantages that exceeded any individual design optimization. German military vehicles showed excellent engineering in isolation, but the variety of designs created logistics nightmares that degraded operational capability. American standardization, appearing crude and inefficient to German engineers, created strategic advantages through simplified logistics, universal parts availability, and reduced training requirements. The lesson applied beyond military vehicles to entire industrial systems. Standardized mass production, properly executed, defeated customized craftsmanship. Democratic industrial mobilization proved superior to authoritarian systems. American factories operated by free workers outproduced German factories using slave labor. American innovation, encouraged through suggestions from workers and competition between companies, solved problems faster than German centralized planning. American logistics, built on cooperation between military and civilian sectors, sustained operations that German command economies could not match. The superiority of democratic organization was not ideological assertion, but demonstrated fact, measured in production statistics and military outcomes. The psychological impact on German military leadership proved profound. Officers who had begun the war confident in German superiority ended it, understanding that modern warfare required industrial capacity Germany lacked. General Oberst Heinz Guderian, architect of Blitzkrieg doctrine, wrote in his post-war memoirs that German defeat was inevitable once American industrial production reached full output. The mathematical ratios, he noted, made victory impossible regardless of tactical excellence. One German truck facing 14 American trucks could not win through superior engineering. One German division supplied by horse-drawn wagons could not defeat an American division supplied by motorized convoys. The numbers told the story of the war more clearly than any battlefield narrative. Generaloberst Alfred Jodl, in testimony before his execution for war crimes, stated that American logistics won the war in Europe. Soviet armies provided the manpower and absorbed the casualties. British intelligence provided strategic direction, but American trucks, ships, and aircraft delivered the material that made victory possible. The observation was accurate. Lend-Lease provided the Soviet Union with over 400,000 trucks, dramatically improving Red Army mobility. British forces in North Africa and Italy operated substantially on American logistics. Free French forces were entirely equipped and supplied by American production. The Deuce-and-a-Half, unglamorous and utilitarian, enabled victory through the practical reality of moving supplies where they were needed when they were needed. The story of German attitudes toward American trucks traces a familiar arc. Initial dismissal based on superficial assessment gave way to grudging recognition as combat experience accumulated. Recognition evolved into genuine admiration and finally desperate attempts to capture and operate American equipment. This progression reflected the broader story of the war. German military culture, confident in its technical and tactical superiority, encountered an enemy that won through industrial production and organizational efficiency. The American way of war, appearing crude and wasteful to German professionals, proved devastatingly effective through sheer material abundance enabled by standardized mass production. The ultimate lesson transcended specific vehicles or technologies. Modern industrialized warfare belonged to nations capable of mobilizing entire populations and industrial bases for sustained conflict. Germany, despite early advantages and undeniable military skill, could not compete with American industrial production once fully mobilized. The Deuce-and-a-Half embodied this reality. It was not the most sophisticated truck design possible. German engineers could identify numerous technical improvements, but sophistication mattered less than production volume, reliability, and logistics support. America built 560,000 trucks to standardized specifications, supported them with universal spare parts, operated them with trained drivers, and maintained them with simple tools. This combination proved decisive. When German forces surrendered in May 1945, American trucks were everywhere in Europe. They lined roads, filled supply depots, and crowded captured German military facilities. German soldiers, seeing the endless rows of identical olive-drab trucks, understood viscerally what statistics had revealed intellectually. They had fought an enemy with industrial capacity beyond anything their leaders had imagined. The trucks themselves, simple and utilitarian, represented American power more clearly than any weapon. They were the visible manifestation of an industrial system that could produce unlimited material while sustaining civilian prosperity. German forces had fought courageously and skillfully, but courage and skill could not overcome an enemy whose factories produced trucks faster than combat could destroy them. The post-war years saw surplus Deuce-and-a-Halfs scattered across Europe. The Marshall Plan used American trucks to rebuild European infrastructure. Relief organizations distributed supplies using military vehicles converted to civilian use. German civilians, rebuilding from destruction, drove American trucks to haul building materials and transport goods. The vehicles that had carried supplies for armies, now carried materials for reconstruction. The irony was not lost on anyone. German industry, which had failed to produce adequate military trucks during the war, rebuilt using American vehicles designed for war but adaptable to peace. Today, restored CCKW trucks appear in military vehicle collections and historical reenactments. Enthusiasts maintain these 70-year-old vehicles in running condition, testament to engineering durability that exceeded all expectations. The sight of a Deuce-and-a-Half, painted in authentic olive drab with white star markings, evokes an era when American industrial might reshape the world. The truck itself, utilitarian and unglamorous, represents the practical engineering and organizational efficiency that defeated fascism and enabled democratic victory. The German generals who watched American supply convoys in 1944 and 45 understood what they were seeing. Those endless columns of identical trucks, running with mechanical precision, carrying unlimited supplies, represented a form of military power their nation could not match. The Deuce-and-a-Half conquered every terrain not through revolutionary technology, but through standardized production, robust engineering, and logistics systems that treated vehicles as consumable resources rather than precious assets. This approach to warfare, appearing wasteful and inefficient to traditional military minds, proved devastatingly effective and became the model for all future mechanized military operations. The lesson endures. Industrial capacity and organizational efficiency, when properly mobilized, determine strategic outcomes in modern warfare. Technical sophistication matters less than production volume. Individual weapon quality matters less than logistics systems. The nation that can build, maintain, and operate vast fleets of standardized equipment holds decisive advantages. The Deuce-and-a-Half proved this truth across every continent and every terrain type where American forces operated, demonstrating that democratic industrial mobilization could create military power that dictatorship could not match, and establishing principles of mechanized warfare that remain valid 8 decades later. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.